There's a piece of Bermuda that has nothing to do with a triangle, and everything to do with something buried far beneath your feet. Scientists just found a massive structure hiding deep under the island, something that shouldn't exist where it does. Bermuda sits in the middle of the ocean, far from any active volcano, far from any plate boundary. And yet, deep underground, there's a hot, dense mass of rock the size of a small country, quietly sitting there like it's been waiting to be found. This isn't a conspiracy, it's not aliens, it's not a hidden city, it's geology, and it might rewrite what we thought we knew about how entire islands are born. And by the end of this video, you'll never look at Bermuda the same way again. Most people think of Bermuda as a tropical postcard, pink sand, turquoise water, maybe a ghost story about disappearing ships. If you paid attention in school, you might know it's a coral island sitting on top of an old volcanic base. Simple enough, right? Volcano erupts, cools down, coral grows on top, tourists show up centuries later. Here's the problem. Volcanoes don't just appear in the middle of the ocean for no reason. Normally, they form along plate boundaries, the cracks and seams where Earth's crust is either pulling apart or crashing together. Bermuda is nowhere near one of those. It's sitting in the dead center of the North American plate, hundreds of miles from the nearest edge. So why is there a volcanic island sitting exactly there? For decades, that question didn't have a clean answer. Scientists knew the volcano existed, they just didn't know what powered it. Now there are new clues. What's actually underneath Bermuda? Why did it form in the wrong place? And could this same hidden process be happening somewhere else, right now, without anyone noticing? So let's go deeper than anyone has ever taken you before. To understand Bermuda, you have to stop thinking of the ground beneath your feet as something fixed. Under the crust sits the mantle, a layer of rock so hot it behaves like thick honey, moving at a pace you'd need centuries to notice. It doesn't melt into liquid the way lava does. It just flows, incredibly slowly, driven by heat rising from deep inside the planet. Think of a pot of thick soup on low heat. Hot soup rises from the bottom, spreads out near the top, cools slightly, and sinks back down. Earth's mantle does something similar, just on a scale of millions of years instead of minutes. Sometimes, instead of a slow, even flow, a narrow column of unusually hot rock rises straight up from deep inside the mantle, almost like a blowtorch aimed at the underside of the crust. Scientists call this a mantle plume. It doesn't care where the plate boundaries are, it just pushes upward wherever it happens to be. Hawaii is the textbook example. There's no plate edge anywhere near Hawaii either, just a plume that's been punching through the crust for tens of millions of years, creating island after island as the Pacific plate slides over it. But here's the part that nobody talks about. Bermuda might be sitting on the exact same kind of feature, just older, quieter, and mostly finished. Here's the did you know moment. Researchers studying seismic waves, essentially sound wave echoes bouncing through the Earth, found something huge sitting deep beneath Bermuda, a structure hotter and denser than the surrounding mantle rock, roughly the size of a small country, sitting hundreds of miles down. This is the leftover root of whatever powered Bermuda's ancient volcano. It's not active anymore in any dramatic sense, but it's still there, still distinct, still detectable, a fossil of a process that happened tens of millions of years ago and never fully faded. Bermuda isn't just an island. It might be the surface scar of something enormous underneath. What textbooks tell you, islands form at plate boundaries. Volcanoes are edge phenomena, simple, clean, predictable. What geologists actually deal with. The planet doesn't follow the textbook diagram. Plumes and hidden mantle structures punch through the rules constantly, and entire islands, seamounts, and hotspots exist precisely because of features that don't show up on a standard plate tectonics map. This matters for more than curiosity. Engineers and geologists mapping the ocean floor for cables, oil platforms, and even offshore wind farms have to account for hidden structures like this one, because they can affect everything from seismic risk to how the crust settles over time. A structure like the one under Bermuda changes the density and temperature of the rock around it, which can subtly shift how earthquakes travel, how heat flows, even how the seafloor has shifted over millions of years. There's a real historical parallel here. For decades, engineers underestimated buried geological anomalies when planning undersea infrastructure, until deep-sea cable failures and unexpected seismic activity forced a rethink of how thoroughly the seafloor needed to be mapped before building on it. Hidden mass beneath the surface isn't just a science curiosity. It's something people who build things in the ocean have had to learn to respect the hard way. Wait, it gets even more interesting. If a plume can sit hidden under an entire island for tens of millions of years without producing another eruption, that means there could be other quiet, ancient plume roots sitting under parts of the ocean floor right now, completely undetected, simply waiting for someone to point the right instruments in the right direction. The most mind-blowing part? Bermuda might not be unique. It might just be the one we happen to look at closely enough to find. You've probably never thought about the ground under your feet as anything other than, well, ground. But this same logic, hidden heat sources reshaping what's on the surface, plays into things you interact with more than you'd think. Take geothermal energy. Iceland, parts of the western US, and other regions tap directly into heat rising from below to generate electricity and heat buildings. That heat often traces back to the same category of process, mantle heat finding its way toward the surface, sometimes through plumes, sometimes through thinner crust. Understanding exactly where and how that heat concentrates is directly useful for finding new geothermal sites. There's also a surprising parallel closer to home. Next time you notice a pot of water on the stove, how the bubbles form unevenly, rising from certain hot spots on the bottom before the rest of the water even starts moving, you're watching a tiny, fast version of the exact same physics driving mantle plumes. Same principle, wildly different scale, from your kitchen to the middle of the Atlantic, and this is just the beginning of how deep this goes. Now here's something most people never connect to this topic. Some scientists think mantle plumes like the one under Bermuda might not just sit still, they might slowly drift, dragged along by the deep, sluggish currents of the mantle itself over tens of millions of years. If that's true, the route under Bermuda today might not be exactly where the original volcano-forming plume started. It could have wandered slightly over unimaginable stretches of time, like a candle flame drifting in a barely perceptible breeze, except the breeze is solid rock flowing at the pace of continents. That means the map of hidden hot structures under the ocean isn't fixed. It's part of a process still quietly playing out beneath every ocean on the planet, one that could shape islands not yet born. Let's bring it back. Bermuda isn't sitting on a plate edge. It's sitting on the leftover root of an ancient mantle plume. That plume built a volcano where none should exist. And the same hidden process might be quietly happening in places we haven't mapped yet. Here's the big takeaway. The surface of this planet is shaped as much by what's hidden beneath it as by what we can see on top. Now I want to know, did you ever imagine there was something this massive sitting under a small island you've probably only heard of because of ghost stories? Drop it in the comments. In our next video, we're going somewhere even most engineers haven't thought about. The hidden reason entire coastlines slowly sink without a single earthquake ever happening. This is Logivra, the logic behind everything, even the ground you thought you understood.